All right. Digital signatures. My name's Kid New. Oh, no, they're already. Okay. We're going to talk about the purpose, the concepts, drawbacks, and a few other things as well. Okay. Purpose. First of all, has anyone ever used a digital signature? Most of us nowadays have used them. Okay. Not all of us, but most of us have. Okay. It's to really signify intent. Okay. It says authentication and approval. I sign this. Okay. I did something yesterday. I had to sign it with my digital signature. It was really just my name I typed in. But I had to do that, okay? It gives security. It's also a ceremony. So, you ever seen, what is it, the president's got that special pen that when he signs bills, he signs one with one pen, he gives it to somebody. You've seen that.
Yeah, it's a signing ceremony.
Yes, there you go, signing ceremony. Yeah, signing ceremony. But yeah, a signature does a lot of stuff for us. There's some things nowadays that could not be done automatically. Does anyone know the items that cannot be done digitally have to be done with an actual signature? A mortgage is one. Because it's something that actually can retain value after you're dead and gone. It can be passed on to somebody else, and you want to be able to track it back to the owner. There's a few.
Anything you have to notarize, but you have to specifically sign
That sounds right, yeah. Anything to be notarized, yeah. But there's a few things that, it's getting to the point where more and more you don't need to sign stuff. It's like our credit cards. What is it, $50 limit now on credit cards before it needs a signature? On some store, something like that?
Yeah, it is.
Yeah. So I could steal your card. I could have a good old weekend with it before you realized it. So. All right. Confidentiality. Everybody know what that is? Hopefully. You've all been in this program long enough, you should know that. Integrity, again, unchanged. Identification authentication is not forged. Okay. Non-repudiation. Y'all should have heard that, but in case you don't know what it is, I know you did it. I have proof you did it. That's what non-repudiation means. That's really what a signature is for. Okay. I was actually on the cruise ship this last week, and had an issue with the spa. Virginia went to the spa, and they charged her. Then they charged you the wrong amount. So then they charged you the correct amount. Then they charged you the third time. And naturally, they messed it all up. So we had to get that all fixed. But they finally got it fixed. But we were down there getting it fixed, and there was a guy down there complaining about a Snickers bar. He's like, I see a Snickers bar on my bill. And you're like, okay, you bought a Snickers bar. He's like, no, I don't eat candy. I never have candy. He goes, I don't even know where you sell candy on this boat. He said, well, maybe your wife did. Because my wife's diabetic. She doesn't eat candy. And he's like, no, you're removing it. Unless you can show me the signed receipt. Because you do sign for everything. They couldn't produce it. So they did remove it. So it was, they couldn't prove that he didn't do it. So, all right.
Probably the boat staff.
Probably.
Charge it to his room.
Yeah. All right. Drawbacks of a signature. Lifting, forgery, document. Anyone seen this movie? Catch Me If You Can?
Awesome.
That's a really good movie. Okay, there are issues with signatures. Okay. We're going to talk about some of them. All right, email. Everybody know what email is? Plain text, no authentication for the most part. Some of them do have it. For the most part, there's really no authentication. Can't be trusted. Y'all know you can edit email messages? That you just bring up a message, go actions, edit message, change it, done. It's very simple to do. And the bad part is, email is considered a business use, which means it's admissible in law, in court. And yet I can change it. And if I change this email and save it on my computer, no one can prove it was not changed. Because the mail server delivers it to me. And it's not going to have a change date on it or anything. So it's actually kind of scary that people, we do so much with email nowadays.
So you're telling me email wasn't a smoke signal with a rug, fire, and smoke this whole time?
Yeah, it's just scary. Okay, do y'all know what symmetric and asymmetric is? Both of them on the test, by the way. Okay? All right, symmetric. Okay? Same key. Symmetric, S, same key. Okay? But there's a problem with sharing them. How can we share keys? Anyone remember? What was the thing we just learned last assignment? Diffie-Hellman, very good. Okay? You know how to calculate how many keys there are? Okay? Asymmetric is also known as public key cryptography. We share keys now. There's the formula for calculating those keys. Okay? but we have to get the key distributed, and it can usually be done through PGP or something like that. Speaking of that, I need to verify my key. Okay. All right. Solutions and more problems. So we're going to talk about digital signatures, hashing problems, key problems. We're going to talk about a lot of stuff. I think they're each covered separately. Okay. Digital signatures. Here's how they work. Okay. First of all, not encrypting the message. We're hashing the message. Remember when we talked about one-way hash functions? So if you take something and hash it, you're going to get a unique value to that item. If the item is modified in any way, and you rehash it, it's no longer the same. With a digital signature, okay, you hash the message in order to get a fingerprint of the message. Then you encrypt the hash, not the message, just the hash. With a private key, that's your signature. Okay? Send the unencrypted messages with the signature. So with this encrypted hash, and then they can get your public key and find out that it's not been modified. And it's a very, very simple and effective process. But what happens if someone doesn't check the signature? Like a prime example of that is getting something from the military. Like Bill Richards used to teach for us all the time, works at DISA. And they have their own PKI digital certificates inside of DISA. They don't work outside. In other words, the certificate authority does not work outside the military. So when I received a message from him, I would always get there's a problem with this digital signature. Every time. Because I can't verify the key. Okay? Now, does it mean the email were forged? No, it just means I couldn't verify it automatically because I don't have this public key to check it with. Okay? All right. So the recipient can read the message, and they can be verified and unchanged. Again, if I don't verify with the key, I could be reading a false email. So whatever I'm getting from Bill might be modified because I cannot verify with his key. Okay? So the sender can be verified as correct as well. When you get into security commerce, you're going to be doing the PGP. I think Eileen might even do it. Does Eileen do the PGP? Anyone know? Anyone have it yet? Okay. Well, there's an assignment that I know is in security commerce where we actually do where you have to create a public key, PGP, and I have the students all submit an assignment with the same name. You're not allowed to put your name anywhere on it, and the file name has to be identical so that I cannot tell who it is without verifying your digital signature. And I do that just so I can verify, hey, I opened it up. Oh, the digital signature says Scott, so I know it came from Scott. So that's what it's all about, okay? Okay. So how does it work? It says rehash the message. So I received a message from Bill Richards. I rehash it. Okay. Then I get the public key to decrypt the signature and then compare the hashes. Now with Bill, I couldn't do that because I could not get his public key. His public key is internal to the military. Everybody with me so far?
So what happens when you respond back to him?
If I respond back to him, I don't have a digital signature, so he gets the message with no signature. Okay. Yeah. Now inside the military, like when Bill Richards sends something to another person inside of DISA, since they have their own certificate authority internally, his certificate's automatically verified. But if his message was, changed at all, say someone went and edited the email, it would no longer match. Because the signature would say, whoa, this is not the right hash value of the message. So, again, he wasn't sending me top secret data either. I mean, just sending me regular emails. Okay, hashing problems. So if two messages have the same hash, then they have the same signature. Is that true? That's an issue. Okay. It says effectively the signer has signed everything with the same hash. So I have two identical messages. They both have the same hash. That is an issue. Okay. How do you fix it? We'll use a different algorithm. Okay. Some are better than others. MD5 has a known collision. What a collision means is two different items produce the same hash. Okay. That's called a collision. With MD5, if you have a certain linked message and you change a certain bit in it, so now you have two different messages, it'll produce the same hash. It's a very minuscule flaw, and it only happens, it's kind of like way back when they released the Pentium 66s. Did anyone buy one back then? None of you are probably old enough to do that. Well, they came out with a floating point error. It was like, when doing floating point calculations, at like the 4,000th decimal place, it could be off by one. for 99.9% of the people out there, it's never going to affect us. But there was a flaw. So what did they do? We all got brand new processor for free. So now we know MD5, the collision is so minuscule that, but the problem is there is a collision. We know there's a problem. It's like, remember the volts were all exploding, catching on fire? That they found out it was not a problem at all. You know, it's people, push this stuff out of proportion all the time. Okay. Key problems. How do we know that the public key you're using to validate the message belongs to the sender? How do I? So Scott sends me something encrypted with PGP. Okay. I download Scott's public key. So I open it. It says it came from Scott. But how do I really know Scott's the one who sent it to me? What if someone else actually had access to Scott's system? Or what if it was someone with the same name? That could happen. So there are issues. Okay. Because what if the true sender's private key is compromised? What if Scott's happened to Microsoft a few years back? Their keys were compromised, and you could authenticate stuff incorrectly, basically. Okay. So there are issues. Okay. How can we do that? With digital IDs. Okay. It has a name, has an address, a public key, a date range, certificate number. This is basically what your bank has. If you ever get a certificate, when I ran my ISP, I made certificates for a whole bunch of companies. I had to verify, what I would do is I would go online, and I would register my system or their website with these certificate authorities. And I had to provide all the information about them. And when I first started doing this back in the mid-90s, it was funny because the certificate authorities would say, oh, this is a corporate company. We need proof of incorporation. Please send us incorporation documents. Well, the first time, I think I sent them to them. Then the next time I got busy and I didn't send them to them. Then like 3 days later, I got the certificate in the mail. I'm like, I didn't send them the proof. And they sent the documents anyway. So the next time, I didn't send the proof again, and they sent them anyway. It was kind of, I found it was one of those, they would ask you for it, but they weren't waiting on it to approve it. In other words, they weren't validating my identity, which kind of sucked.
Damn.
Yeah, that's what was happening. Yeah, it was literally, they said, oh yes, we need corporation paperwork, and you just wait 3 days, it comes in an email. And I was like, wow, yeah, it sucked. It's different now.
Okay, I hope so.
Yeah, it is different now. But, back in the mid-90s, security, who really
Yeah.
cared? Who really cared? Okay? But you're providing all this information, and you have a certificate chain. In other words, who verifies? Like VeriSign. Yeah, when you go to like D2L or your email, there's always that lock on there. That's managed by someone. Komodo, VeriSign, GeoTrust, or somebody like that. So who's the certificate chain? And there's something called the PKI infrastructure that manages that. Okay? It's hardware, software, people, policies, everything working together to verify your identity. Okay? And it's a really good system. You can actually get your own. If you go to pgp.com, I'm pretty sure there you can do it. You can actually get your own private signature, digital signature for your email. It's free. And it's not a bad thing to have. I mean, do you need it? No. But it's getting to the point we're doing so much more stuff electronically that it might get to the point where we need that. I don't know. Okay? But it's a whole collection, it's an infrastructure to get it secured. Okay? And they talk about something here called certificate revocation is now possible. Initially, like when I ran my company, I sold certificates. Okay? I was a reseller for certificates. You would buy them from me, I would get them and sell them to you. Made a good profit on it. It was kind of nice because VeriSign would sell them for $350. I'd buy them for $80, resell them for $350. I was selling them for the same price, but they were only costing me $80, so it was a good deal. But way back when I first started doing this, they gave me a 10-year certificate, a free one. Since I was a reseller, it was good for 10 years. What are the odds that the same system, because this is not for me, it was for the system that hosted my website. What are the odds that the entire system is not going to change in 10 years? There's something going to change. So but back then, when I first started doing this, you could, once a certificate was issued, it was good forever. But that sucks. What happens if it gets compromised? Carol steals my system.
Why Carol got stuff? She's
Because she said, okay, Bobby stole my system. Okay. So Bobby steals my system, and I can't call up someone and say, hey, someone just stole my system. Can you revoke my certificate? You couldn't do it back then, so it really sucked, but now you can. Okay. All right. And it goes into much more in-depth than security commerce on that. Okay. Okay, confidentiality. They talk about the nested safe. In other words, one thing inside of another. Okay. It says it's encrypted message. It says encrypt the message, not just the message digest, with the receiver's public key. Now we're actually encrypting the message itself. Okay. Remember, confidentiality is different than a digital signature. Digital signature, we didn't care really if people saw the message. We just wanted to verify that the message was real. Now we want to make sure it's confidential. Okay. So we encrypt the message now with the key. Then encrypt the results using your own private key. The result, both the sender and receiver are assured that no one else could have had. In the security commerce, going a whole bunch more in depth on that, and we do both ways. So you not even have a thing where I send the student something, and they can verify it came from me, and they're the only ones that can open it and stuff like that. Okay. All right, ethics. What do you think of all these phishing scams out there and social engineering? Is that an issue nowadays?
Yeah.
That's a real big issue nowadays. It's just everywhere. It's that new one, Crypto Locker, the new virus out there. You all hear about that one? It actually encrypts your hard drive with a public key system. It gives you, I think it's an hour. The last one I saw said like 58 minutes. It starts counting down. You got to pay them the money within that time period to retrieve the public key to decrypt it, or they delete the key. Done. Once that key's deleted, your system is never coming back. There is no fix for it. So don't get that virus. If you do, hopefully you have a good backup, because you ain't decrypted. It's not doing it. So, bad stuff. Okay. So handwriting signatures are unreliable. Do you all know they do not teach handwriting anymore in school? My stepkids did not go through the entire alphabet in cursive.
Really?
They didn't have time. So I says, you didn't finish the end of it? No, we only got through part of it. I'm like, when I was in school, that was a big deal. We had to know that like perfectly. They don't have to do that anymore. A signature now can be a block letter.
What?
Thing. Yeah, that is a valid signature.
I swear, if my nephew or niece tries to I almost smack
Yeah, I'm telling you, that's what's happening.
Like, do a Z right now. Do a Z.
It says digital signature provides solutions but create new problems. Okay,
Wow.
and new problems can be solved. Okay, so there's always, whatever we come up with, there's always more problems that come with it. Okay, how about a date? Pretty hard to prove dates. Okay. We're not going to cover that in here, but I mean, just something to think about. How do you prove when you signed something? So we know Carol signed it, or Josh signed it. When did he sign it? That's a whole other story. Okay. All right. That's the end of this lecture, and all the references up there. This stuff's already up on D2L, by the way. All right.